this system using the substitution property, because f of x and g of x could both be replaced with the letter y. So we can say that 0.4x squared, I can put the 0 in front of that, minus 1.2x minus 1 equals negative 0.1x squared plus 0.8x plus 8.5. And if you're like me, you don't like to work with decimals when you're solving equations. So what I would do is multiply both sides of this equation by 10, because that'll move all the decimal points one place to the right, and we will be working with integers. So I would be doing this: 4x squared minus 12x minus 10 equals negative x squared plus 8x plus 85. Then this is a quadratic equation. We got to get it equal to 0. 5x squared, moving all the terms on the right to the left side, minus 20x minus 95 equals 0. And when you're solving any equation, you can divide both sides by the same number if you want to. And I can see that every term is divisible by 5. So I might as well make the numbers easier to work with. X squared minus 4x, 95 divided by 5, I think, is 19. And I can see that there are no multiples of negative 19 that are going to have a difference of 4. So this indeed is not going to factor. So using the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4 times a is 1 times c is negative 19 all over 2a, which is just 2. And the number under the radical is 4 times 19 is 76 plus 16, 92 over 2, all over 2. Square root of 92 simplifies to 2 radical 23. And every term in the numerator and denominator is divisible by 2. Oh, so I was supposed to go to full board here. Giving us 2 roots, 2 plus or minus the square root of 23. Okay. And of course, the problem asks us to round our answers to 3 decimal places, find the points of intersection. So I'm going to share my screen, go to Desmos, and we'll see what these look like. So there are our functions, f of x and g of x. And I set x sub 1 equal to 2 plus the square root of 23, x sub 2 equal to 2 minus the square root of 23. And I plotted the points x sub 1, comma, f of x sub 1. And that is this point right here. And then I plotted the point x sub 2, comma, f of x sub 2. So these are the decimal values for the 2 roots. You can round those to 3 decimal places. It's like 6.796 and negative 2.796. And of course, the corresponding y values are here. Okay, and you could also plot the points x sub 1, g of x sub 1, and they better be in the same location as the previously graphed points of intersection, and indeed it is. Okay, so that's one technique for finding the points of intersection of 2 quadratic functions. So I will end the answer and hope you understood all that.